and activity coefficient is factor used thermodynamics to account for deviation from ideal behavior in a mixture of chemical substances. In an ideal mixture, the microscopic interaction between each pair of chemical phases are the same or macroscopic equivalent. The enthalpy change between enthalpy change of solution and volume variation of mixing in is zero, and as a result property of a mixture can be expressed directly in terms of simple concentration or partial pressure of the substance present. Raoult law. Deviation from ideality are accommodated by modifying the concentration by activity coefficient. Analogous expression involving gas can be adjusted for non-ideality by scaling partial pressure by frugality. The chemical potential mu b of a substance be in ideal mixturing of liquid or an ideal solution is given by mu b equal mu b theta plus RT in XB, where mu b is chemical potential for pure substance B and XB is mole fraction of the substance in the mixture. This is generalized to include non-ideal behavior rating. Mu b is equal mu b theta plus RT in AB. Ionic solution. For solution of substance with ions is solution, the activity coefficient of the cation of anion cannot be experimentally determined independently of each other because solution properties depend on both ion. Single ion activity coefficient must be linked to the activity coefficient of the dissolved electrolyte, as if undissociated. In this case, amine stoichiometry activity coefficient of the dissolved electrolyte gamma plus minus is used. In it is called stoichiometry because the express bout of deviation from the ideality of the solution and incomplete ionic dissociation of ionic compound which occurs especially with the increase of the concentration. Electrolyte such as NaCl is given the following: gamma plus minus for A1 divide 1 electrolyte such as it given by following gamma plus minus square equal gamma plus gamma minus, where gamma plus and gamma minus are the activity coefficient of cation and anion respective. More generally, the mean activity coefficient for compound of formula A, P, B, K is given by gamma plus minus P plus K root gamma A P gamma B K. Single ion activity coefficient can be calculated theoretical, for example, by using the Debye-Huckel equation. The theoretical equation can be tested by combining the calculation single ion activity coefficient to give mere values which can be compared to experimental values. The prevailing views that single ion activity coefficients are unmeasurable, independent, or perhaps even physical meaning has its roots in the word Guggenheim in late 1912. However, chemists have never been able to give up of the idea of single ion activity and, by implication, single ion activity coefficient. For example, pH is defined as the negative logarithm of the hydrogen ion activity. If the prevailing views on physical meaning measurability of the ion activity is correct, then defining pH as the negative logarithm of the hydrogen ion activity place quantity squarely in the unmeasurable category. Recognizing this logical difficult, International Union of Pure and Applied Chemistry, or UPAC, state that the activity definition of pH is not a definition online. Despite the prevailing negative view, the measurability of single coefficient, the concept of single ion activity continue to be discussed in literature, and least one author present definition of single ion activity them purely thermodynamic quantities and proffers of method of measuring single ion activity coefficient based on purely thermodynamic process. Concentrasi solution of electrolytes. For concentrasi ionic solution, the hydration of ion must be taken into consideration, as done by Stokes and Robinson in their hydration model from 100 and 1948. The activity coefficient of the electrolyte is split into electric and statistical component by E. Gluekoff, who modifies the Robinson-Stokes model. The statistical part include hydration index number H, the number of ions from the dissociation, and the ratio R between the apparent molar volume of the electrolyte and molar volume of water and molality. B. Consideration solution statistical part of activity coefficient is in yes is H min P divide P in 1 plus BR divide 15.5 min H divide P in 1 min BR divide 55.5 plus BR time R plus H min P divide 55.5 time 1 plus BR. The Stokes-Robinson model has been analyzed and improved by other investigators as well. Application to chemical equilibrium. At equilibrium, the sum of the chemical potential of the reactant is equal to the sum of the chemical potential of the product. That gives free energy change for reaction. Delta RG is equal to the difference between this sum, and therefore at equilibrium is equal to 0. Thus, for an equilibrium such as alpha A plus beta B to be S plus T, delta RD is mu S plus mu T min alpha mu A plus beta mu B equal 0. K is S T divide A B. Peter Debye and Debye-Huckel developed a theory that would allow us calculate mean ionic activity coefficient of solution gamma plus minus and could explain how the behavior of ion in solution contributed to this concern. Assumption of Debye-Huckel theory. The Debye-Huckel theory is based on three assumptions how to ion in solution. First, electrolytes completely dissociate into ion in solution. Second, solution of electrolyte are very dilute on the order of 0.01 molar. Third, each ion is surrounded by ion the opposite charge on a break. Debye and Huckel developed the following equation to calculate the mean ionic activity coefficient gamma plus minus equal log gamma plus minus mean 1824 times 10⁻83 divide 2 z plus z e square root 5 times 5 times 8 times 2, 5 times 8 times 2 log gamma plus minus equal 100 I'm sorry, 1824 times 183 divide to z plus z mean e, where